Hi, good morning. Today we are going to see about NAND and NOR implementation under the unit minimization techniques and logic gates. Belong to the subject of digital principles and computer organization. Today, in previous videos, we have discussed about minimization techniques and minimization laws and how what are the logic gates that are that we are using, what are the functions of logic gates, and how to minimize the techniques, how to minimize the terms. These are covered in previous video. Now we are going to discuss about the NAND and NOR implementation. In NAND and NOR implementation, any Boolean function can be created using AND, OR, and NOT gates. And NOT gates can be implemented by using NAND and NOR gates. That's why it is called as universal gates. Mm, NAND and NOT gates are a fundamental building blocks in digital electronics. They are universal gates, meaning any other gate can be implemented using just NAND and NOR gates. NAND gate is just an opposite of AND gate. An AND gate output 0 only when it inputs are 1. The truth table of NAND gate and uh, NAND gate is just an opposite of AND gate, and NOR gate is just an opposite of OR gate. NAND and NOT implementations of NAND gate, NAND implementation and implementation of NOT and using NAND gates. NAND gate with single input act like a NOT gate, and as a NAND gate it is the inverter of AND. So by putting an inverter of output of NAND, we can have AND gate. NOT gate were given to the AND gate, it becomes a NAND gate. NAND gate and output we are given as not given to the NOT gate. Output of AND gate is given to NOT gate. Then the output of NOT gate will be the NAND gate function. This is the symbolic equivalence of NAND gate. Here we are giving three input, and the output will be x, y, z complement. It is similar. The NOT gate is the each input is complement of each input is given to OR gate. That also similar to NAND gate. NOR implementation of OR gate using NOR gate, as NOR is the inverter of OR gate. So by putting an inverter in the output of NOR, we can get OR gate. OR gate, first is the symbol of OR gate, and an OR implementation by using OR gate. By giving a OR gate output is given to the NOT gate, then it becomes a NOR gate. Graphical equivalence of NOR gate. By De Morgan's law, we can describe NOR gate graphically by the following symbols. We are giving directly three inputs that are given to the OR gate, and it gets complemented by using NOT gate. Then the output will be x plus y plus z whole complement. Similarly, we are inverting the each input x, y, and z. Then we are given it to the AND gate. The output will be the same for what we are getting in previous symbol. That means x complement, y complement, z complement, that will be equal to x plus y plus z whole complement. This is the NAND and NOR implementations. NAND is the bubbled OR according to the De Morgan's theorem. Here simplifying the given logical expression and convert it in the SOP form, and then draw the AND or NOT relation techniques and replace every AND gate by a NAND, and every OR gate by a bubbled OR gate, and a NOT gate by a NAND inverter. Finally draw the circuit using only NAND gates. This is the example we have given a directly NAND gate. The output will be AB plus CD plus CDE plus F. NOR implementation, here the bubbled NOR equal to bubbled AND. Here the expression convert it into POS form and draw AND or NOT relation. Replace every OR gate by NOR, AND gate by bubbled AND gate, and invert by a NOR inverter. Finally draw the final circuit is the only NOR gates by using only NOR gates. This is the example. Here how we are converting the how we are implementing the NOR gate. Assessment is how can we AND gates be implemented by using NAND gates. And what is the output of NOR gate when both the inputs are 0? Create a circuit using only NOR gates to implement the functionality of NOR gate, AND gate, and OR gate. NAND and NOR is the universal gate. We can design any type of GAN by any type of gates by using NAND and NOR gate. By for accessing this question, you can understand the NOR and NAND implementation. Thank you.